Hello my dear students, welcome to this video. In this video, we will discuss the preparation of phenols from various compounds like halobenzenes, cumene, sulfonic acid, etc. That is, we are dealing with the industrial synthesis or industrial preparations of phenols. The first method is a Dow process. That is, in this process, phenol is prepared from chlorobenzene. In this process, the chlorobenzene is treated with alkali, say 10% NaOH, at a high temperature and pressure, say 350 degrees Celsius and 200 atmosphere pressure. And in the presence of diphenyl ether is a catalyst here, sodium phenate is formed, which is then acidified to get phenol. This is the reaction chlorobenzene. Chlorobenzene is treated with 10% NaOH, temperature 350 degrees, pressure 200 atmosphere. When this chlorine is replaced by ONA, that is sodium phenate is formed. Actually, this is the sodium salt of phenol, which can be from which phenol may be obtained by the acidification process. Acidification process may also be carried out with the carbonated water, when sodium carbonate will be liberated and we will get phenol. Next is the Raschig's method. Again, in this method, actually chlorobenzene is prepared by passing a mixture of benzene and HCl gas and air over heated ferric chloride or cupric chloride at say about some 250 degrees Celsius. The chlorobenzene thus formed is hydrolyzed by superheated steam at a temperature of nearly 425 degrees Celsius when phenol is obtained. The entire reaction may be depicted as like this: phenol, which with HCl, of course, HCl is in the gaseous phase, HCl, and in presence of oxygen, and our catalyst is ferric chloride, temperature 250, we are actually getting chlorobenzene. This chlorobenzene thus formed when steam is passed, say superheated steam, say at a temperature of 425 degrees Celsius, and under pressure, phenol is obtained. Now the third method is a direct oxidation of benzene. Here phenol can be manufactured directly by the oxidation of benzene, but here the catalyst is vanadium pentoxide and a high temperature of 320 degrees is applied when we'll get phenol. Next method is a fusion of sodium benzene sulfonate. Phenol may be prepared from sodium benzene sulfonate. Actually, sodium benzene sulfonate is actually melted or fused with NaOH at a temperature of 350 degrees Celsius when sodium phenoxide is formed. The sodium phenoxide thus formed may be acidified to get phenol. Next is an odd process. This is a very special process. Here we can see a sulfonation process. That is benzene. Here the starting compound is benzene. Benzene is heated with concentrated sulfuric acid. When sulfonation takes place, and we'll get benzene sulfonic acid. This benzene sulfonic acid, this is the detailed structure of benzene sulfonic acid. This benzene sulfonic acid, when treated with sodium sulfite, the sodium salt of benzene sulfonic acid, namely sodium benzene sulfonate, is formed along with the sulfur dioxide gas and water. In the third step, the sodium benzene sulfonate is fused with the sodium hydroxide. This reaction we have already seen when sodium phenate is formed. This sodium phenate, along with this sodium phenate, we are getting sodium sulfite and water. The sodium phenate thus formed can be decomposed in the presence of sulfur dioxide and water to get phenol. The speciality of this reaction is that sulfur dioxide is actually generated in the step 2, that is used in step 4, and the sodium sulfite generated in steps 3 and 4. This is step 3. Here sodium sulfate is generated. This is step 4. Again sodium sulfite is generated. These sodium sulfite generated in steps 3 and 4 can be utilized in step 2 also. See, this is the case. So there are several special ways of obtaining phenol on a commercial scale, and one of the dominant technology in the commercial production of phenol is a cumene process. This process actually starts with the compound cumene. That cumene is actually isopropyl benzene. First of all, we will see the preparation of cumene. Cumene is prepared by the Friedel and Crafts reaction between benzene and propylene in the presence of anhydrous aluminum chloride. We know that Friedel and Crafts reaction is always catalyzed by anhydrous aluminum chloride, and here the final product is isopropyl benzene. This is the isopropyl group and the compound is isopropyl benzene. This is what we call as cumene. Now we will see the preparation of phenol from cumene. Cumene, when treated with air, it undergoes oxidation, that is aerial oxidation. Aerial oxidation of cumene produce what is called cumene hydroperoxide. This is the reaction. The cumene, when treated with air, this is isopropyl benzene. This when treated with air, the oxygen in air actually reacts with cumene, and this is the reactive center. At this center, this oxygen reacts to give this type of peroxide linkage. Oxygen peroxide linkage will be formed. Now, when this cumene hydroperoxide is treated with concentrated sulfuric acid, it undergoes decomposition reaction to give phenol and acetone. This is how the reaction proceeds. See, decomposition takes place like this to give acetone, and the remaining part will be added as phenol. So both of these compounds, acetone and phenol, are of commercial importance. So hope the reaction is clear to you. Thank you.